All right, hello everyone. Welcome to WebM Open Video Playback in HTML5. We have myself, Kevin Carle, here from Google, also Jim Bankoski. And from Brightcove, we have Bob Mason and actually also David Mendels. Yes. You can follow along on Wave and ask questions and do Google Moderator. So like I said, I'm a software engineer at YouTube. I work on latency and HTML5. So today we're going to cover a couple things. First off, we're going to go over a little bit of an overview of HTML5 video, go through some benefits, what it does for us and for the user, and go through some of what we've been doing at YouTube with HTML5 in the last year. And then Jim's going to take it over and start talking about WebM, and we're going to go into some specifics about what is WebM and VP8 and performance and that sort of thing. And then we're going to have some demos from YouTube and Brightcove of WebM playing in our HTML5 players. And then some summaries of just some of the experiences we've had developing for HTML5 in the last year. And then we'll go to questions. So what is HTML5 video? So most of you probably know this stuff, but essentially HTML5 has introduced media tags so that now we have audio and video as first-class HTML tags along with everything else. So now the media player can be part of the browser and you don't need a plugin to be instantiated. Otherwise, it acts like any other tag, and you can see that the simplest possible example of video tag is pretty much up there. That would start a little player using the browser's built-in controls playing a video. And one other thing I wanted to cover up front here is just that we're going to be using the words codecs and containers a lot. Again, most of you probably know what that is, but for those who don't, a codec is something that encodes and decodes a video. It's software that basically tells a video, explains how the video's information is organized and how to play it back. And a container is a file that wraps the video, the audio, other content associated with the media object and describes what it is and where it is. So what are the reasons that we want the video tag in HTML5? Well, the biggest reason is really just that it's open. So you now have the ability to have an open source browser with a media player built in and an open source video codec and video container. And so now anyone can implement the full stack all the way from the video itself to the player. And so we'll have a lot of different implementations out there and a lot of competition, a lot of innovation in the space. These next two reasons are fairly similar, but there's a lot of opportunity for improvements in latency and performance. These will vary a bit, of course. They're not guaranteed. But for latency, for example, you won't have to instantiate and download a plugin. So at the very least, you've got one fewer resource request, assuming you package all your JavaScript and CSS together the way you normally would. And depending on how the browser implements it, you can get better performance, assuming that they take advantage of hardware and so on. So the other advantage, of course, is the video tag it's a video tag. So if you have a screen reader or other accessibility software, they know that it's a video and they can handle it appropriately. Similarly, if you've got a search indexer or anything that's walking over the HTML page, it knows it's a video and not just some sort of obtuse plugin where it doesn't know what's inside. So what have we been doing with the video tag at YouTube? Well, we've had a player up for a couple months now on youtube.com/HTML5 using the H.264 codec. As of today, we are announcing that we have WebM videos available on the site. For now, if you want to find WebM-specific videos, when you do a search, you can append and WebM equals 1 to the search URL. We'll clean that up a bit soon and have a UI option for that. As far as the browsers we support with HTML5, it's pretty much everything at this point. In Chrome, we now support H.264 and WebM. WebM, of course, only on the newest Chromium builds. If you go to the WebM project website, I believe there are links to all the browsers builds that support WebM. Safari, we support video tag with H.264. Opera and Firefox, we will have support, again, on those kind of tip-of-tree builds there that have WebM support, and that'll be rolled out more later. And on IE9, we will have support as soon as they release a preview version, essentially with the video tag, which should be in preview release 3. And they would definitely support H.264, and today they announced they would be supporting VP8 through Direct Show, I believe, so if you have that installed. So that should give us quite a few options there. We don't currently support certain advanced overlays like ads and annotations, which are implemented in Flash on our site. We will be working on support for those as time goes on. We did just add this week caption support. So right now it's actually only the default caption track. We still need to implement the menu and selection and all that fun stuff, but it should give you the default caption track for your language if the video has captions. And that's just done using JavaScript and the canvas tag for now. So looking at video formats that we have at YouTube, we support H.264 and WebM now. Both formats are going to be supported for uploads going forward. For H.264, every video on the site is basically available in H.264. We have them in MP4 container at 3 resolutions, 360p, 720p, and 1080p. And then in FLV container, we have some additional formats like 480p. Right now, I don't know of any browser that supports the FLV container in HTML5 tag, although there's nothing really stopping them from it. It is an open specification, so if that ever happened, we could potentially provide those additional formats in HTML5. For WebM, so currently we will be transcoding all new 720p and above uploads in WebM. We will eventually expand that to all new uploads, and we will also be going through and transcoding our existing catalog of videos into WebM. So we'll take a little while as we get 24 plus hours of video a minute, so we'll be working on that. So we currently have the WebM videos available in 360p and 720p, and we'll be adding additional formats over time. So what can we not do with HTML5 right now? Well, the biggest issue that the users will notice, I think, is full screen. So there is full screen support in WebKit and in Firefox. Neither currently allows you to full screen anything other than the video itself. So the problem is, if you want to be able to implement your own controls and things like the captions, which you've implemented through JavaScript, those will not be available in full screen. And then many other browsers don't have any current support for full screen. Our short-term plan is that we're going to give you the ability to expand the player to fill the browser. That should be coming out soon. And then you can full screen the browser or just maximize it or whatever. We do hope that eventually there will be some support for scriptable and media element full screening in browsers, so that if you can implement, take part of the page like a canvas or something and expand it to full screen. But we don't know if that will happen. Another issue is embedding. So right now, most sites on the web, of course, do video embedding through the object tag with Flash. So that doesn't, the object tag, while it technically can be used for HTML5, it doesn't work very well. It's not very supported. So really, iframe is the best option. Then you can include the controls, the JavaScript, everything you need to have your own player experience. But the big issue with that, of course, is that not everything allows you to embed an iframe right now. So we'll be talking with and working with sites in the community to push that kind of forward. Live streaming, there's no real spec for live streaming right now in HTML5. That's something that can come. Something that we've only recently started doing ourselves. Stream management. So right now, the browser pretty much handles all the aspects of loading and displaying the video. In Flash, you get a little more control over the network streams and visibility into what's going on. Some of that would be nice in HTML5. It's not there now. Content protection. Some content owners rely on this to make their content available, and right now there's no official support for this in HTML5. And then a big one is just that the implementations in the spec are still in motion. I'm sure a lot of web developers are familiar with this kind of thing. All the browsers implement it a little differently, and there's still debate going on as to how best to handle certain things. So that just it makes it a little extra fun when developing. And then from a YouTube perspective, we also have the issue of ads. So on a normal browser on desktop, if you have Flash, we can display the ads in Flash, the video in HTML5, that's fine. Obviously, some devices aren't going to have Flash, and so on those, we won't be able to support videos where the content owner requires ads. And that's another thing that we just need to work with the ad community on, essentially, is getting more content available in HTML5 for ads, which is certainly doable. So now I'll turn over to Jim to talk about WebM.
Hi. I'm Jim Bankoski. I'm an engineering manager at Google, but until recently I worked at a small company called On2 Technologies. On2 was a pioneer in video codec technology. We started in 1992 doing video game machines like the Sega Saturn and Sega Dreamcast. We also did video in PC games like Final Fantasy VII and a bunch of other games. Up until probably 2002, 2004, we had a deal with Electronic Arts, and we're in The Sims 2. We're also, around 2000, we started doing internet video with our site. And we've been adopted since then by Flash, so our friends from Macromedia and Adobe, and then Skype and AOL Instant Messenger, and now in Java and Sun's Java FX, I'm sorry. Basically, we add up and we come to a number around 2 billion installs by summing up all the numbers of the installs of these things. In 2010, about 2 months ago, in February, we were acquired by Google. So it's been a very busy set of 2 months. We went from our codec, where it was at On2 to a released open source product today. So you can imagine it's been a very busy couple of months. In any case, we're excited about what's happened, and let me talk about what WebM video is exactly. WebM is a kind of a container format that we borrowed. We borrowed a spec from the core codec team, who created a format called Matruska. Matruska can contain video and audio and some other things. For us, in the WebM spec, we're talking about purely Vorbis audio codec and the VP8 video codec. The Vorbis audio codec is from a team called Ziff. It's a great audio codec. We think very highly of it. VP8 is a codec that we developed at On2 and is now what we open source today. Move on. So what's great about WebM? We think the video quality is great. We think that you'll see that it's not blurry, it's sharp, there's not blocks. We compare favorably with other codecs that are out. We have strong playback performance, or fast playback performance. In other words, it'll play on your low-end processors, your Atoms, your Snapdragons, running on cell phones and the like. We also have great live two-way encoder performance. We mentioned on the last slide that Skype was a user of ours. We do very well in real-time performance. Also, obviously, we're open, and that means that anybody can download and use it in any way that they see fit. We think that has some very unique advantages. You won't be paying a royalty. I'm sure you've seen, we've got some great hardware support coming out of the gate. We have a lot of vendors that have already jumped up and said, we're going to support this format. And we'll have a slide to talk about each of these. Sorry, I don't want to give short shift. We also have a lot of tools support from companies like Sorensen and various others who are providing encoders that will produce our video format, or this, I keep calling it our video format. It's an open video format. I'm going to talk a little bit about video quality. This is a PSNR graph. I'm sure unless you've worked with video before, you have no idea what this means. So I'm going to talk a little bit about that. There are two axes. On the horizontal axis is bit rate in kilobits per second. On the vertical axis is basically a metric of quality. It's called PSNR. If you were to take a look at, you follow along a straight line across, you're basically saying all of these points have the same video quality. So for us here, if you follow the fixed quality across to about 2,800 kilobits, you'll see that VP8 achieved on this clip a PSNR of 25.5. Following the 25.5 line across, you come to about 3,400 kilobits for 264. So on this specific clip with the settings that we use, we got about 600 kilobit savings over the 264. We've tested this on a lot of different clips. On 2, we had about 70 clips that we were typically using that cut from high def down to QSIF. So that's high def being 1080p, so 1920 pixels by 1080. High, 720p, 1280, 720, all the way down to image sizes like 176 by 144. We've done, we do very well. We compare very favorably against other codecs like 264 on a very wide set. Now that we've become part of Google, obviously we have a much larger test set. We can talk about hundreds of thousands of videos as opposed to the 70 that we're talking about now. So I'm just sliding through these. I don't think anybody needs to, I can tell you that each one of the graphs that I'm showing you is, we are in fact comparing favorably, but that is not to say that we always win. There are clips that we are not doing as well on. One thing we're also doing quite well on is playback performance, but there's a couple of caveats when I show these graphs. First, the comparisons that we're doing, I'm running in single core mode. The codec does support multiple cores decoding, but we haven't done a great job on that yet, and we're going to. I'll talk about some of the to-dos at a later point. Another thing that I should mention is the comparisons done in software. We're not using hardware acceleration, and there is some hardware acceleration for 264 that are on PCs and cell phones today. And so I wanted to point that out. Basically, we are about 20%. Oh, one final thing. We haven't fully optimized our decoder yet. We're not using the two most recent instruction sets from Intel and AMD, the SSE2 instruction set or the SSE3 instruction set. So we think that we can actually get a good boost over where we are today in performance. Right now we have a couple of profiles. Our profile 0, which is our highest quality, maybe slowest to decode, is running about 15 to 20% faster than 264 in its high profile, on high profile material. P0, which is our P1 rather, which is our profile that competes well with baseline, is actually slower today on the newest machines. But we think, and I'll show you another slide now, that if you take SSE 2 and 3 out of the equation by going to an older machine, in fact, our P1 is our profile 1 is actually performing faster than baseline. So I think you'll see that we are, we compare very favorably to these codecs on a playback performance side. We also, I don't want to skip over, Atom is a very important processor because it's used in a lot of netbooks today, and Chrome OS will be supporting Atom. We are performing quite well on the Atom processor in comparison to software decodes of 264. Snapdragon is a processor that uses an ARM Neon instruction set. It's in your Nexus 1 phones if you have them. We perform quite well. We can just about do 720p in software. As long as you're not doing anything else. If you had to do audio decode in software or something along those lines, you'd have a little bit of trouble. But we're very, very, very close. I also mentioned earlier that we do well at live compress, live or two-way compression. We actually have, inside of our compressor, we have 16 different internal complexities that we can switch between. We can, on a typical, I think it was a 2-core, we can run about 3 milliseconds per frame for 640, 480 software compress. And we can use as much as you're willing to give up in terms of cycles, up to somewhere around 45 milliseconds per frame. So we'll get better quality if we spend more time. The blue line in the back that you see is actually a line that describes our codec as of 2 months earlier. I want to point out that we've been rapidly improving this codec, and we think that there's quite a bit more that we can do to improve it further. I don't want to neglect our friends at ARM. We also have an encoder for ARM processors. This is that same Snapdragon. And here we're basically able to do 640, 480 at 30 frames per second, again, using 100% of the CPU right now. We think we can do better, but that's where we are. I talked about another advantage being openness, and I think Kevin hit on that. Here's one way that you can contribute, and that's to go to our website, webmproject.org, and download the source code and start making check-ins. We are very serious about the fact that we want community involvement. It is our plan to support two kind of different bit streams, one which will be bitstream compliant and will stay with that bitstream, and another for experimentation that's outside of the straight bit stream. And in that case, we're talking about wild ideas that people have to improve the codec. There's a lot of things that we think that people could do, the community could do. There's for instance, if you're familiar with digital cinema, the people that do digital cinema do not use typical RGB with 8 bits for R, 8 bits for G, and 8 bits for B. They go up to 10 bits or even 12 bits. That's something we haven't done in our codec yet. That's a feature that we think that somebody using our codec could add. There's other things, obviously, if you guys know about security cameras, if you've ever seen dome cameras where they're taking a picture and the video is, they're actually capturing through a dome, so they get a 360 view. We imagine that those guys have specific needs around how the motion moves. So we are very serious about our willingness to accept contributions, and we have kind of 2 tracks for doing that. And I mentioned earlier that we have a couple of things we haven't done yet. Faster decoding is one of them. We think that we can get very strong improvements by doing some multi-core stuff that we haven't yet gotten in. We haven't used the SSE2 or SSE3 instruction sets. We haven't done much with GPU decoding yet. All of these things are areas that we are currently working on, and we hope to get in soon. We also think that we can improve the quality of the codec in a lot of different ways. There's features that we could add. We also think one of the things that we did in our release is our best quality mode is pretty darn slow. We think we can do a lot better in our best quality mode to make it a lot faster, and that that'll have a good impact on people producing the absolute best quality that we have. We also think that there's subjective quality improvements that we could do. Imagine that there's a person standing in front of a screen and there's white noise playing in the background. Really, you want the compressor to do a good job, potentially focusing on the person's face as opposed to the stuff in the white noise in the background. Our compressor right now doesn't do anything like that, and I think we could do a lot better. And we have some internal features that we're using, we've defined in the bitstream, but really haven't fully implemented except in a researchy way. In other words, we know that they're beneficial, but we don't have them in a production build yet. So we think that we can get a lot better than we are today, and we think we will in a short term, and we also hope that the community will help us do this. In terms of the browsers that support WebM, if you sat through Sindar's keynote speech, you saw that, that Mozilla Firefox will be supporting it. Opera is supporting it. Obviously, our own browser, Chromium, and Chrome will be supporting it. And we're really hopeful that everybody else will. I mean, we'd love to see Internet Explorer and Safari on board supporting this. All of this info you can find on webmproject.org. So you can go and find where to download these browsers and to start playing with them. We talked about industry support. If you went to Sindar's keynote, you saw the same slide. There are a lot of software vendors, people that are using it right out of the gate for things like video conferencing. There are vendors that will be producing tools that will let you encode in VP or in WebM. There are also a lot of hardware vendors. And I want to point out that just because a name doesn't appear on the list doesn't mean that they aren't working with us and moving forward. There are a lot of people that are, I think you'll see that in the coming days that there will be more of these. And I'm going to pass it over to Kevin again to show you the demo of VP8 playing in YouTube.
All right, so you can see this is the normal YouTube watch page. If you opt in, like I said, through /HTML5, you can get the HTML5 browser wherever your web browser will support it. If you're on one that doesn't support H.264, you'll only see it for videos with WebM. If you're on, say, Chrome, you'll see it for pretty much all videos. Some nice little visual things here so that you can see, that you're on HTML5. We have the HTML5 logo, and we also have a WebM logo when you're playing in the WebM format. And that's just me not knowing how to use a Mac, sorry. So you can see it there. This is the Chrome speed test video that was released recently. And this is the 1280 by 720 version. And we updated the player this week. If you've seen our Flash player in the last, month or so, then it has this new look. And we updated the HTML5 player this week to match. So we have all the new controls here. And in our videos with captions, you'll see the captions and so on. So there's the new player.
Oh.
And I think switch back here.
Well introduce them.
Here, you switch back.
Okay, I would like to introduce Dave Mendels.
Fine. Give us a second, get a presentation up. Hi, I'm David. It's nice to meet you. It's a cool event. I want to thank the folks at Google for having us. It's exciting to be here. It's exciting to be one of the partners in the WebM announcement. Is the microphone working? I think that was human error, not microphone error. I was too far away. I'll say again, I'm David Mendels. Thank you to Google for having us here. It's a great event, really cool. We're excited to be one of the partners involved in the WebM announcement. And I wanted to talk a little bit about video and what Brightcove's doing and what we're going to be doing with WebM. So, first of all, when you think about video on the web, there's lots of different problems to solve. And a lot of people who haven't thought about it and haven't published video think, oh, it's just about playing a video. You got to, you need a video tag, or you need a flash player, you need a play button, and you play a video. And the fact is the playback problem is probably the simplest problem that people have. There's a whole range of problems that people have when they want to do complex publishing that involves video. So playback is the simplest problem, but today even that has become increasingly complex because of the fragmentation of the runtime environments, whether are you targeting Flash? Are you targeting HTML5? Are you targeting both, depending on which device you're on? Are you doing different form factors for different devices? Flash Player 10.1, HTML5 on devices, iPhone and iPad, et cetera. And so there's increasing complexity even on the playback side. But when we talk to our customers, and we are involved in publishing and streaming, on tens of thousands of web properties, hundreds of millions of videos, and billions of video plays a month. The set of problems that our customers are dealing with and that we try to help our customers with are much more than just playing back the video. So how do you create an experience that you can encapsulate and share into a Facebook stream? How do you do subtitling and closed captioning? How do you get analytics on that video? How do you do engagement analytics? How do you do audience demographics? How do you do advertising insertions and pre-rolls and mid-rolls and post-rolls and overlays? How do you do it with an ad network? How do you do it with an ad server? And I could go on. There's just a wide range of things up here that you have to do across a wide range of platforms. And it's a complicated world. There's a lot of fragmentation today in what you have to deal with. So briefly, what Brightcove is, because some of you might know who we are and some of you might not. We're a cloud-based online video platform. So we got the cloud right there in the middle. So what does that mean? What we do for our customers is you upload a video to us, and we take care of encoding it in the cloud into multiple renditions at different bit rates and different codecs. And then we provide metadata management. We will generate players. We have a means of customizing those players, integrating them with Twitter or with Facebook. We have ways to integrate analytics, both our own analytics as well as Google Analytics, as well as other third parties like Nielsen or Omniture or Quantcast. And then we provide all of the hooks to integrate with basically any ad technology out there for video advertising on the web, if you want to do that. If you don't want to do that, great, that's great too. And so that's what we do. And so we solve that whole range of problems end to end from, hey, I have a video, I want to play it, I want to know who's watching it, I want to monetize that with advertising, and I don't want to manage all of that complexity across different devices. And on the playback side, we do that across different screens. So we do HTML5 if you come to a device today from iPhone or iPad, and also Android or other devices. We do Flash. And our aim is to make that process really simpler. So every content publisher in the world doesn't also have to manage this complex matrix of browsers, Flash players, codecs, but they can focus on publishing video, whatever their business model or communication strategy is around publishing video, and then we can take care of detecting that device and going forward, detect the device, detect the runtime, and then select the right rendition and the right player to play back. So our news today is pretty straightforward, is that we are adding to that mix of stuff we're doing support for WebM. And somebody asked me earlier today, so why are you doing WebM? And it's a pretty straightforward answer. It's good, it's free, and it's open. Not a very complicated story. We think that's a great thing for the web. Our whole business and our whole vision revolves around more and more people being able to publish video, whatever video experiences they're trying to create, whether that's personal or commercial, whether it's entertainment or news or any other kind of communication. So the easier it is for people to do that, across devices, across browsers, across different experiences, the better. So we think WebM's a great thing. We will still support H.264. We support H.264 today. And we'll do both across both Flash and HTML5 so that whatever device you're targeting, you can get a great playback experience and a great user experience. So we're not interested in our customers being collateral damage in the platform wars among different vendors here who are fighting for one platform or another. Our take is, if you have video content to publish, we will help you publish it. We'll get it in the right format, in the right device, at the right time. And so WebM will be a core part of that, and we've already got it up and running. It's in our cloud-based encoding. We'll have a demo to show you in a minute, and that'll be available to all of our customers later in the year. And our customers, just to give you some perspective, range from Sony Music that might be doing tens of thousands of music videos, or the New York Times, or Fox Entertainment if you watch House or 24, any of those shows, all the way down to individual churches or nonprofits. So we range the whole gamut of customers, and anybody interested in publishing can take advantage of Brightcove either through a set of user interfaces, or we provide REST-based APIs for everything we do. So if you're a developer, you're building applications, you're building content management systems, and you want to integrate with a video publishing system that will help you take advantage of WebM, help you publish those players without having to do all the work yourselves, you can take advantage of the plumbing we've basically built in the cloud. So that's what we do. And the last piece is I just want to introduce Bob Mason. Bob is our co-founder and CTO, and we have a demo that involves playing some videos.
Thanks, David. What I want to illustrate here is a sample application that we built as part of this effort. What I wanted to sort of demonstrate is this ability for us to do device detection, understanding the capabilities of the different platforms, and then actually rendering out the appropriate experiences. So on my computer here, I have a vanilla install of Firefox, Safari, and one of the latest builds of Chrome. So if I go here to Firefox, you can see that this is a standard Flash player. Nothing remarkable or interesting around that on its own, but it gives great playback experiences, and there's a huge amount of ecosystem support on advertising integrations, dynamic streaming playback. It's a really robust delivery platform. But if I now go to Safari, what I want to sort of illustrate here is this is actually an HTML5 experience. So as this page is getting loaded, there's a series of REST-based APIs and device detection code that actually can determine what capabilities this end user has. And we're rendering out an HTML5 experience that has high fidelity compared to a Flash experience. And you can see in this circumstance here with this video that it's actually an H.264 video that's being rendered in this circumstance. But if I go to the Chrome version, it's an identical HTML5 experience, but the main difference here being is that we're actually running VP8 video through this process. So you can see it's actually working. The way this system is managed, the content can get uploaded, encoded. We actually store multiple renditions, and then the logic at the runtime is advanced enough to understand the best way to optimize the user experience based on what device and what platform they're connecting to and what capabilities. Thank you. And I think we're done in its questions now,
I
right?
have one more slide.
Okay.
So we can switch back.
You got to switch back.
So
over there.
2, right?
Sorry, let me get in.
Or I guess it's 1.
I'm going to get back to. Except that's going to start you over. Yeah, there's one too.
There we go. All right, so we just had one quick slide here, just sharing some of the development experiences we've had at YouTube, and then we'll lead right into the questions. So one thing that might be helpful for anyone who wants to play around with this on YouTube, if you add the and debug equals true, we're using some closure stuff there to output debug information to logs. You can see what video formats are available for that video, which one we've chosen for you, all sorts of fun things. You can also just, if you want to go with HTML5 for a particular video, you can add and HTML5 equals true. With all these, though, and including with the opt-in, one thing I don't think it was entirely clear on earlier is that if the video is monetized, we will still show you Flash because we have to show the ads. And that's something we're working on. Like I said before, if you want to find WebM videos, you can add the and WebM equals 1 parameter to your search. And we'll probably have a UI option for that under the advanced search soon. So some choices we made in development. We're not using a lot of the HTML5 semantic tags for some of the video controls, such as like the progress element. And this is because of issues around styling, CSS support for those tags, and just general browser support. So, but speaking of CSS, one nice thing is that when you're working in HTML5, you pretty much know you're working in a modern browser, so we can use things like CSS3 and a lot of things where you don't have to worry so much about supporting the older browsers. One thing that we've been working on is the whole concept of the way we do fallback content and source selection. We don't actually use the source tags in the video. Like, we don't render them out initially. We actually do some JavaScript before we create them because we want to be able to have a little more control over which source we choose based for the user. And then we also are working on implementing the switch back to Flash on the client side if for some reason, even though we think on the server you'll be able to use HTML5, but you really can't. Like I said, we're not making HTML5 default for any browser yet, but that should be soon. So one nice thing about HTML5, of course, is that it's supported on a lot of devices. What you get is, the device support is a little odd on many of them. You don't actually get the controls and so on. If there's a video element, it'll actually full screen then the video element automatically, like on some phones and tablets and so on. So that's just something to keep in mind. You won't always have that control, even if you do create the controls yourself. One nice thing that actually got removed in the UI this week, we'll be back soon, is there's client-side support for variable speed playback in HTML5. There's just a property called playback speed, and you can set that to whatever you want. We had that last week. It'll be back. One thing that we found on seeking was that it was better to pause the video, do the seek, and then replay than to just seek. That's something that maybe that'll be fixed in some of the browsers, but right now we were getting a big performance advantage to doing that versus just issuing a seek command. One other thing is that when we do the progress bar rendering, we originally were relying on the time update events, but again, we found that a lot of browsers would stop firing the time update events periodically. This is probably a bug that will get fixed, but in the meantime, we actually have a timer that fires every 500 milliseconds, and if no time update events have happened within that time, we'll just go ahead and update progress bar that way. So we needed that fallback in order to keep it from just stalling out much of the time. So I'm going to open it to questions. I also wanted to mention first that we have a YouTube developer mixer tomorrow at 6 p.m. at Jillian's across 4th Street. I'll have tickets for that anyone can pick up if they want in this chair over here. And then I think we're on to questions.